The scientific method. So we will move on now from talking about the ways we know things to the scientific method, which is what sciences in general use to use to make observations. So we will talk about these in detail as we go through, and I'm sure most of you have touched on these before in other courses, in high school science courses, things like that. So we've got things like developing a hypothesis, selecting a measure. Rather than only a measure, I would say developing a study rather than just selecting a measure. Gathering objective data, or running the study. Analyzing the results, and publishing, criticizing, and replicating the results. For example, what we just discussed with Milgram. He published the results that so many people would shock all the way to 450 volts. Other people criticized and then replicated, and they all saw that, wow, these observations were accurate, this many people do actually shock. So let's talk about these in more detail, starting with developing a hypothesis. And this is something that I would really like for all the students to have a good understanding of, especially those students who are psychology or social science majors. But all of the students should have a good sense of the scientific method and the way that psychology knows things, so that in the future you will not be misled by things claiming to be real psychology, real science, when they actually are not. So I want you to pay particular attention to this section in your book in Chapter 2, and pay particular attention to things like what the difference between correlation and causation is, and look at the third person problem, the fact that the evidence in some cases can be explained by a third variable that we don't know to begin with. But that's a little aside. So let's talk about the 5 methods of hypothesis generation. In general, hypotheses can be developed through theory. They might be data-driven, question-driven, or observation-driven. So let's talk about these in detail. This is a text-heavy slide, and I apologize about that. But I do want you to have this information, but I would rather have you read this quickly. Just pause the video, read this quickly, and then listen to my explanation, or listen to my explanation of these things, and then pause the video to read it to give you a little better understanding of these 5 methods. So this first, logical deduction, in other words, reasoning. We have a theory already, and theory X implies that B will result from A. So if we hypothesize that X is true, producing A will result in the occurrence of B. So we're just, if you see, we're switching those around. If we hypothesize that the theory is true, producing A will result in B happening. So, for example, our theory says if you direct people through a authority, through an experimenter who looks like they know what they're talking about, if you direct them to shock people, they probably will shock people even though they might be a good person in general. So the theory is X, good people will do bad things when directed to by an authority. So we produce that. We produce A, an authority, and then we see B, we see the shocking of the individuals. Using conflicting findings is a common method of hypothesis generation. Oftentimes there are extra variables that could cause an effect that we see in our results, and we need to build a new hypothesis and test those new variables, or control for those new variables. And there's a lot more I could say about that. There's a lot more I could say about all of these methods of hypothesis generation. But suffice it to say, you can use the findings that are conflicting, that say something else is causing this, to think, well, maybe it is another variable, test some new variables, essentially. In this third, we already discussed this with the Milgram example, observing seemingly paradoxical behavior. It was paradoxical. They didn't expect that that many people would shock the participants all the way up to 450 volts. Another example is that many members of religious organizations or cults are more adamant about their leader being a prophet or something of the sort after a certain prophecy has failed. This has been seen time and time again with different end-of-the-world cults and end-of-the-world religions. So it's a paradoxical behavior. You see that and you say, well, what in the world? That is not what I would expect. The person prophesied the end of the world would come this day in this manner. It didn't happen, but now the members of this cult think that this person is telling the truth. They redouble their efforts in gaining converts and things like that. So it's paradoxical behavior, strange things. Another way that's similar to the previous is by observing common behavioral tactics. So just the normal things that people do every day. You might be a people watcher. You might say, well, why do people do that? Why do some people open the door for others and some people don't? Just normal kind of behavioral questions can start scientists thinking about hypotheses. Lay people do this as well. Make up hypotheses of why people act the way they do. Another method that we use is case studies. And this, I'm sure you've heard the term case studies before. It's intense focus on one individual or a few individuals to find a relationship among variables. And this is often used when a situation or an illness or something like that is very rare and hard to study. When there's not a lot of people who are experiencing these things, it's really useful to use a case study and then try to generalize it and find new evidence later on. So those are the primary methods of hypothesis generation. So then we move on to selecting a measure, and I would say rather than calling this step selecting a measure, I would call this step creating a study or developing a study, because first of all, we need to figure out what we want to test and how. We need to decide, do we want to use something like field observation to study human behavior? Like, do we want to sit outside a building and watch people do certain things, just see their normal actions and code that, write it down? Do we want to run an experiment, put two different groups through different situations and have one control group and one experimental group? Or do we want to measure this through a paper survey? The measures are important. They're a big part of developing a study, but there is a lot more that goes into developing a study. So one key part of developing a study and selecting a measure I want to talk about and is discussed in your text is reliability and validity. So reliability, in essence, is, does the test measure things consistently? Does it measure the same time and time again? So you can look at an example of a scale over here. A reliable measure is if you are 175 pounds, you step on the scale today and you get 175 pounds. If you step on the scale tomorrow, you get 175 pounds, or maybe 174.5. That's showing that it's measuring consistently. Each time you step on it, it's measuring the same way. Or if you put something that you know is 10 pounds on there, maybe a weight, every time it will say it's 10 pounds. That's reliability. It will reliably give you the same measure each time. So you can have scales that aren't reliable. Oftentimes when using surveys with children, we find that they're unreliable because the children tend to be kind of just answer boxes. They're kind of like random number generators. In some cases, when you ask them certain questions about something that they don't really understand, they're just going to say something. They're just going to put A, B, C, or D. They won't understand it, and then the next time they're going to put something completely different, and your test will have no reliability. Using the scale example, an unreliable scale might be one that's broken, where you put your 10-pound weight onto the scale. The first time it will say 10 pounds. Then the next time it might say 5 pounds. The next time it might say 20 pounds, where you know this is a 10-pound weight. That would be an unreliable physical scale right there. Validity is different, and sometimes it's harder for students to comprehend. It's basically, does the test or does the measure actually measure what it is supposed to? And so those of you who are continuing on in social science, it's really important to understand the difference between these two things. And for the test as well, these are important concepts to understand. So, validity. A scale is valid when it's measuring weight, like the scale over here. But if we wanted to measure intelligence, IQ, we wouldn't weigh our head. We wouldn't put it here. If we wanted to know what someone's personality type was, we would not set their head on this scale and say their head is a personality type of 7.5 pounds. That's not actually measuring what it's supposed to measure. A valid scale would be one that we are testing for prosocial behavior. And to test for prosocial behavior, we might want to look at empathy and say, okay, if someone is empathetic and claims that they do prosocial behavior, it might be a valid scale. There's different ways to test this, but that's an example of a scale used in psychology that might be valid. Using a prosocial behavior measure where we test them for empathy and then also ask them, how many times have you donated to charity in the past year? Next, we're going to gathering data. So once you have your measure selected, once you have developed your study, you're going to run the study. You're going to gather your data. You're going to go out, set up your experiment, you're going to set up your field study, and you're going to get your data, however it is. It might be a paper survey. In essence, the definition's right there on the board. It's the information gathered by the researcher to use to test the hypothesis. And again, here's a couple other terms, dependent variable and independent variable, that you're going to have to remember, especially if you're a social science major. These are going to come up in the future forever, essentially. The rest of your life, you're going to be talking about dependent and independent variables. And for those of you who aren't social science majors, it's important to understand so that you know how science gets our answers, how psychology gets our answers, and also for your tests. So a dependent variable is what you measure, is the thing that's actually measured. So in my previous example, it would be prosocial behavior is what we're trying to measure. And if I was doing an experiment to make people be more prosocial, that would what I manipulate would be the independent variable. So the independent variable is whatever is manipulated. And studies can have more than one independent variable, and studies can also have more than one dependent variable, things that we don't manipulate, to check if more than one thing changes because of our independent variable. So again, dependent variable are those things that we measure, that we don't change directly, that we don't manipulate. Independent variable are those things that are manipulated. So our data comes from the dependent variable, and our experiment is done with the independent variable. So if we are trying to make people more prosocial, we might teach them a class, give them a class about being more prosocial, about empathy, about helping other people. We might take them to church on Sunday and see if those people who went to church versus those who didn't are being more prosocial. So that church attendance, in this case, could be an independent variable that we manipulate.